new semester. This is our first video, and we're going to take what we started thinking about exponential functions, and we're going to put some vocab to it. So when I was in one of the groups, Akina was talking about the difference between linear and exponential functions, which was awesome. And I know a lot of you guys started to talk about those relationships when you were comparing the graphs. So if I ask you, a linear function always increases at, you were going to finish that, you would say a constant rate, right? We know that. Linear functions increase at a constant rate, and they change by addition, meaning that if you look at the table, it's adding every time. We did that at the beginning of the year, and that is called the slope. Exponential functions are different. The first couple days, they're increasing slowly, right? You have 1 penny, then 2 pennies, then 4 pennies, then 8 pennies. You don't even have $1 yet, okay? While in the other case, you have about $6,000 before you even come to $1 with the penny. So they increase really, really slowly at first, for a while. All the first 20 days were really slow. 21 was pretty slow. But then in 22 and 23 and 24, it started to grow much faster and faster. And so an exponential function increases slowly at first, and then increases faster and faster, okay? Exponential functions change by multiplication. So if you're looking at the table, it multiplies each time, and that's called the growth factor. So growth or decay. Pause this, write it down. Pause it, write it down, sorry. Okay, and this is really important. This is gonna be in the slideshow, but I want you to have this in your notes. Sorry, I'll move this so that you don't see the smart notebook thing on it, but exponential functions always have a variable in the exponent. So that's the purple X right here. That's the variable in the exponent. And it tells you how many times the growth or decay occurs. Usually that's time, like 28 days, 4 years. If you're investing money and you want to see how much it's going to grow by the time you retire in 30 years, that would be the X, the exponent. The Y is the final amount that you have. The A is the initial amount that you start with. So we started to think about that in class, and a lot of you guys were forgetting about that. We started with that penny. And the B is the growth or decay factor, what it's multiplying by. So pause it, copy everything down the exact way it looks. If you have a highlighter or colored pencils, color it so that you can identify. I'm going to scroll so you can see the bottom part as well. Okay, so pause it, get this, and then make sure you have this written as well. And this is telling you that the B is the growth or decay. Some of you are starting to notice that when B is larger than 1, right, it was growing. But when B was less than 1, was a decimal, it was decaying. Okay, this is the growth or decay factor, and it is the number that you're multiplying by each time. So if it's doubling, you'd be multiplying by 2 each time. The 2 would go here. So pause this, make sure you have everything written down, and then I'm going to continue to the next slide. Okay, these are really important formulas. So write them big, write them clearly, and make sure to organize it the way you see it organized here. Don't just squeeze it into random parts of your notebook. This should be nice and organized. If you do not have a notebook and you need one and you're not able to go to the store to get one, let me know. I can work on getting you one from Amazon or something. But you must be writing in a notebook. Paper towel is not going to fly. Okay, exponential growth. You'll see here that it's this formula, right, that we just saw. Or the B can also be written as 1 plus R. We're going to see that that is when we're given a rate, which is a percent. So B is when we're given a factor. 1 plus R or 1 minus R is when we're given a rate or a percent. An example is y equals 2 to the x power. Exponential decay always has a fraction or a decimal in the parentheses. And that's because we're doing 1 minus the rate, okay? Because it's going down each time. So if it was 1 minus 10%, it would be 1 minus 0.10, which gives you the decimal of 0.90. If it was a fraction like 1/2, that would give you the decimal of 0.50. So the number inside parentheses is always between 0 and 1 because it's that decimal, and that is decay. Make sure you draw the graph so you see what it looks like. And here are 2 examples. You can have the decimal or fraction inside, also a negative exponent. And I want you to think about it. I'm not going to tell you why that would be true. And then a negative exponential function is when the A is negative, not the exponent. So just pay attention to that. Make sure that you paused it there. And now write down what each letter represents. The B is the factor, the R is the rate. Important difference. Ooh, okay, so you have all of that written down. The last thing we're going to learn, and this is the new one, is about compound interest. You've probably heard about this when you hear people talking about investing money. Okay, the stock market, if you're listening to everything that's going on with GameStop right now, all of that has to do with compound interest. So it's a really, really, really important idea. And so I want you to write this formula down. It is very similar to the exponential growth formula, but if you notice, it's got something different here. Instead of just r, it has r over n. And in the exponent, it doesn't just have time, it has n times t, n times time. So what is this n? The n is how many times in a year they recalculate the interest. That's what compounding means. So compounding is recalculating the interest, okay? So the formula is the same. P just means initial amount, the principal amount. Okay, R is your rate, that's a percent that you convert to a decimal. T is the time in years, that's the X. But the difference is this N, which is how many times in a year the interest gets recalculated. So if it's compounded monthly, then they recalculate it 12 times in a year, okay? This is gonna come into play later on, so this is very important. Pause it and write this down. Now we're gonna do some examples. When a problem is talking about growing or decreasing at a certain percentage rate, okay, not a decay factor, a percentage rate, this vocab is gonna be important, we're gonna use this formula. Y is how much you would have after T years, okay, or X years. A is your initial amount, okay. 1 plus R is if it's growing. 1 minus R is if it's decaying. R is the percent that you have to convert to a decimal, and X is the time. So let's do an example.
Pause it, write this down, and then write this example down. You invest $2,000 that grows at a rate of 7% annually. How much do you have after 10 years? So after you write that, we're going to set it up. So we have Y equals, or A equals, okay, the initial amount. So the initial amount is the $2,000. Parenthesis. Since it says grow, I know it's going to be plus R. So I write 1 plus, because we're always starting at the initial amount, which is 1. Then the rate is 7%. So you have to convert that to a decimal. So you divide it by 100, which equals 0.07, and that's the number that you plug in here. And then the exponent is the time, and that's 10 years. So this is the time, this is the initial value, and you just use a calculator, okay? And this is the rate. So you put in 2,000, parenthesis 1 plus 0.07, close parenthesis, exponent 10. And we're going to usually round money. All right, Y equals $3,934.30 because it's money. That's how much money I would have after 10 years. That means that if I invest 2,000, it's growing. It's almost doubling. It's almost 4,000, which is great. But if I invested 10,000, I bet that would be even better, right? Because then you'd have a lot more money. So let's see one more. If you've ever heard about a car depreciating, what that means is that when you buy a car, it loses value, right? Because the minute you drive it off the lot, it's now a used car as opposed to getting a brand spanking new car. So that's depreciate, which is the same as decay, okay? It's going down in value. So we're going to set it up. Y equals, it said I bought the car for 18,000, so that's my initial value. Because it's decay, I'm putting 1 minus. Remember that you have to take the percent, and you have to divide it by 100 to get a decimal, 0.13. And the time in years is 5. So that's all the important information. I always like to underline. Write the example. Write this down as well, okay, in words and the work that we're doing. Type it in your calculator, exactly how it looks. Use one of those apps I told you about, and it gets to 8,971.58 That means that in 5 years, it's lost almost half of its value, okay? So because the 13% is recalculating every year. We're going to do 2 more examples, and then that's it for the notes for today.
So the last one is you're investing $24,000 in an account that's compounded monthly. So as I was saying, the difference between compounding interest and just regular interest is that, and this is what, whenever you're talking about investing money, all of that's compounding, is that it doesn't just wait till the end of the year for them to recalculate how much interest. It will constantly do it, right? It does it, in this case, every month. Okay, so this is really important. So I'm investing $24,000. It's compounding. That's a really important word. And it tells me how often it's compounding, which is monthly. The rate is 5%, and it's asking about 6 years. So we don't know how much we're going to have at the end. We can call that A or Y or whatever you want to call it. P is the initial amount that I invested, which is $24,000. 1 is how much I start with. It's growing, okay, because when you have interest, interest increases, so it's plus. My rate has to be a decimal, so 5% divided by 100 is 0.05. But I have to divide it by how many times it's being compounded. So when it's monthly, that means n equals 12. So I'm going to divide it by 12. And then for my exponent, I put 12 times the time, which is 6 years. Okay, what I'm going to do here, it's almost the exact same thing. The only difference is I am going to put this into my calculator first. So I put 1 plus parenthesis 0.05 divided by 12 close parenthesis. So I'm just going to show that 1 plus, because whenever you put a fraction in, you have to put parentheses around it. And so I just rewrite my equation, and I got 1.00416. I always want to put as many as I can. Minimum is 6 after the decimal, but it's always good to put a little more. And then for the exponent, what is 12 times 6? It's 72. And now I can just type this in my calculator. So I put 24,000. If you want to just type the whole thing in, that's okay too. But you have to use all those decimals because you will get a drastically different answer. And the answer is y equals $32,376.43. So if it compounds more often, you make more money, which is a good thing. So we're going to be learning all about making money with this. The last thing I'm going to go over, that was the last example, is how do we start with an equation? So the population of middle-class adults living in Bushwick has been changing over the last decade. The population can be modeled with this equation. Okay, what is the initial population? Well, that's the A value. So the initial population is 12,000 people. Always talk about what is the story about. It's talking about people, middle-class adults living in Bushwick. Now I have to look here and say, what is my growth factor? Growth factor is the B, so that's just the number inside here. That's 0.87, okay? Is this growth or decay? It's a decimal, so it's decay because it's less than 1. Okay, what is the percent of decay? Well, remember that in parentheses, it's 1 minus R. I have to find out what's that R that equals to the parentheses 0.87. This is how I figure it out. To find the growth rate, since this is our formula, 1 plus R is in parentheses, and that's what the B is, right? The B is the number in parentheses. We know that B equals 1 plus R, right? So R equals B minus 1. That's all I have to do. So I take the number in parentheses, the 0.87, and I subtract 1. And 0.87 minus 1 gives me negative 0.13. But this is the decimal, and I have to convert it to a percent. So you multiply by 100, and it equals to negative 13%, or 13% decay. And that is how you find the growth rate and percent. Have fun, practice, and it'll be due next week. Just the notes are due right now. All right, bye.